So the next process in line is to machine this top surface down 15 thousandths, leaving this pad behind. So we'll have to pick up this top surface, drop down 15 thousandths, clean up everything, and mill to the line here and here. Clean all that up. So it's just, we don't have to pick up the edge or anything, it's just done by eye. So let's get the part hammered down. I picked a 1/2 inch end mill. Let's see. Picked a 1/2 inch end mill with a 1/8 inch radius on the corner. So around the pad it'll look the same as it did when we side milled the rest of it. Inch end mill, we're about 800 RPM, that's about right. So let's just run it down until we touch the top surface of the part. Set the Z-axis to 0. Now I'm going to take all this in one pass, it's only 15 thousandths. So I'm just going to drop down 15 and we'll start milling. Watch your overlap when you're working with a radius like that, because you can't overlap as much as you would with an end mill that had a sharp corner. Now we're just going to mill to the line, right about there. Again, it's just for aesthetics, so it's not real critical. And we got to do the same thing over here, mill to the line, right there, and that's it. Done. All it's left to do is put the 0 mark in it, and we'll set up and do that next. One thing many people don't realize is it's very easy to make special tools out of drill rod for the use in the machine shop. I've made end mills before, I've made form tools. In this case I'm going to make a form tool to cut this 30-degree V groove in the carriage stop body. So what I have is a piece of 01 drill rod, oil hardening drill rod, some ordinary motor oil, okay, nothing special, any kind of motor oil will work just fine. Normally I use a oxyacetylene torch, but not everyone has that, so I'm going to use a propane torch today. That will get a piece this small hot enough. So basically what we're going to do is just heat up the part of the drill rod where we want to grind our tool, quench it in oil, and that'll make it pretty darn hard. It'll be about Rockwell 50 to 53. So let's go ahead and do that. We have to heat the drill rod up to about 1100 degrees or so. It'd be a kind of a cherry red orange color. If you don't get it hot enough, it won't harden as it cools in the oil. The oil's a quench medium. There's different types of drill rod. There's also water hardening, where we use water as a quenching medium. But I like oil better. It's a little more flexible. Water hardening tends to crack when you cool it. You have a intricate shaped tool. Sometimes you'll get cracks in it. Oil hardening doesn't do that as much. It makes a real nice tool bit. I don't know if any of you have seen the videos on my Stevens, but I made a corner, it's kind of a corner rounding, not a corner rounding, but a form end mill to put a radius on the edge of the receiver. And I made that out of 01 drill rod. Worked pretty well. Now you can see we're starting to get orange color. This is about pushing propane to the limit. You really have to work at it to get it hot enough. But it will do it. There we are, we're starting to get a nice orange color now. Okay, so now just plunge it into the oil and swirl it around so it cools as rapidly as you can get it to cool in oil. Just leave it in there till it stops smoking. Plus a little bit so you don't burn your fingers when you touch it. Okay, let's see what we've done here. Okay, that should be a nice hard piece of drill rod. Let's try it out with a file, see if it's file hard. It is. So now we can go ahead and we can grind our form tool using this as our blank. See you at the grinder. Okay, now that we have our piece of drill rod hardened, it's time to grind it into a tool bit that we can use. Since we're going to be cutting a 30-degree V groove in the part, we need to grind that V shape to this piece of drill rod. We have to make it so the end of the drill rod is what does the cutting. It's going to be plunged into our part, so it's going to act like a broach. Okay, only the end is going to cut. So we need to make a 30-degree form. We also have to make sure that form has a little bit of clearance behind it, so it needs to be slightly tapered as it moves up the shank. And I'll show you how to do that. It's not real difficult, but we'll give it a try here. First, we'll just grind a flat on the rod, about a ½ inch long or so, just enough to reach down through our pad where this engraved V cut is going to go. Okay, and I said we had to have a little bit of clearance behind the cutting edge, so we need to angle the shank of the tool into the wheel a little bit. It's probably hard to see from that viewpoint, but I'll exaggerate it. I'm grinding it kind of like this. I'll show you that up close when I get the other side ground as well. You'll be able to see it pretty easy. You see the sparks are coming off a little different now than they would have if you just grind a piece of drill rod that's not hardened. They'll look a lot different. They're kind of fanning out, and that's the kind of spark you get on hardened steel. Okay, got a nice splat on one side. So I'll flip around to the other side. I'll just get it started, then I'm going to check it with my protractor to make sure I'm trying to zero in that 30-degree angle before I go too far. This is kind of hard to line up here. I'm looking at the viewfinder on the camera upside down and backwards. Okay, that's a lot more than 30 degrees, so I'm going to need to make that angle more acute. Better to find out now than after you've got the tool almost finished. Alright, let's see what that looks like. That's closer. Still a little more, a little larger angle than I want. It's probably about 35 degrees. So we'll angle it a little more. Alright, let's see what we have here. Okay, we're still a little fat on that angle. We have to, this is a good point, this is a carbon steel tool. It's not a high-speed tool, high-speed steel. So you have to be aware of the temperature of the tool as you're grinding it. If it starts turning straw color, you need to stop and cool it off. Because you don't need to worry about, or you don't have to worry about that on high-speed steel because it has good hot hardness. Carbon steel doesn't work that way. High-speed steel doesn't start losing its hardness till up around 1,000 or 1,100 degrees. Carbon steel, like this drill rod, starts losing its hardness at about 400 degrees. So if it starts turning color, quench it before it loses all its hardness. Okay, so I'm just working these two flat sides down to a point, trying to maintain that 30-degree angle, included angle. I'm not doing a very good job of it at the moment. See if I can't correct it a little bit. Still pretty fat. Take a little more off this other side. That should be pretty close. Alright, that's real good. Alright, let me just finish up on this. Basically, we're making a knife blade, so we have to be really careful not to overheat it. It's easy to do. Okay, I think we're probably good here. Okay. Alright, we're at 30 degrees. I don't know if you can see it here. Let's see. There you can see it. Okay, it's kind of like a knife shape. Two faces 30 degrees apart. Alright, now the next thing we need to do is grind the end of it. Right now it's just rough on the end. So all we do is just hold it square to the wheel. Grind a nice flat on the end. We don't want to make any back rake on this, so hold it square or perpendicular to the wheel. Something like that. So now it's square on the end, has that 30-degree shape to it. And if you look at it from the side, you can see it angles back a little bit, has a little bit of clearance behind the cutting edge. That's what I was talking about before. Kind of tapers in. So that's all there is to grinding the tool. Now we can just put this in a collet in the mill, plunge it across our part, and it'll make a nice 30-degree groove in the part. I'll probably clean this up a little bit with a stone. Let's make sure the edges are nice and sharp on it. And we should be good to go. So now that we have our tool made, before we move on to the mill and cut this V groove in the part, I'd like to take a time out here and talk about math a little bit. I know some of you guys are heading for the hills right now, but math is important in the shop. I'm not a big math whiz myself, but I realized the importance of it early on in the shop. And I took a lot of math classes, and I forced myself to learn enough to get by. And basic trigonometry and algebra are very useful, in addition to regular math skills. Basic math are very useful in the shop. And here's an application where a little bit of trigonometry goes a long way. We have a 30-degree V-cut to cut in this part. The V-cut's, well, obviously 30 degrees angle, and it's 3/1000ths of an inch wide. So we need to figure out how deep to make that cut, that 30-degree cut, to get our 3/1000ths wide width at the top of it. So let me show you a way to do that. Looking at that cut from the edge, we have a flat surface with a exaggerated V cut in it like that. Obviously from the print, this angle is 30 degrees. Okay, we know the width of the top of the V is 3/1000ths of an inch. So we need to know how deep to make that cut so that 30-degree V-shaped tool ends up, or the cut ends up 3/1000ths of an inch wide at the top. So let me show you how to do that, or one way to do that. If we add a few lines to this drawing I've made here, we can see we can make this triangle into two what they call right angle triangles. Okay, a right angle triangle is a triangle with where the base and the upright side form a right angle. It's pretty self-explanatory. It's a little easier to see if we take and move that triangle, or one of these two triangles, off to the side, like that. Okay, you can see this base is 90 degrees. This is a right triangle. There's some basic trig functions that apply to right triangles. If you look in the Machinery's Handbook, there's a whole section on that. And the cool thing about right triangles is that if we know two parts of this triangle, like maybe an angle and in one side, we can find a third part of it, another angle or another side, from that information. In this case, we know that, well, we know this angle because we know that two of these triangles equal 30 degrees, so one of them is going to be 15 degrees over here. Okay, and we know this short side, two of these guys are equal to 3/1000ths, so one of them is obviously equal to 1.5/1000th, or half that. And what we want to find is the depth, or the length of the base on this right triangle, which is the unknown in this case, x. Okay, so here we know this angle here, we know the opposite side, and from those two knowns we can calculate this one unknown that we need to find. Okay, what we're going to be using in this case is called the tangent function. Tangent function states that tangent of an angle, in this case 15 degrees, equals the opposite side, which is 0.0015, divided by the adjacent side, which in this case is x, our unknown. Okay, x is this side right here, the depth of the cut that we're looking for. Okay, now we apply a little bit of algebra. We need to solve this equation for x. First thing we need to do is get x out of the denominator on this side, and we do that by multiplying both sides of the equation by x. So that gives us x tangent 15 degrees equals 0.0015. Okay, so now we got x over here. We have no more fractions to mess up our equation, but we still have to isolate x. We still have to solve for x. So the next step we need to do is we need to divide each side of the equation by tangent of 15 degrees. And that leaves us with x equals 0.0015 divided by tangent 15 degrees. Okay, we're starting to get it a little more simplified here. Next step we need to do is figure out what the heck the tangent of 15 degrees is. For that we need a calculator or a chart. Tangent of 15 degrees, and we grab my calculator here. Just find, most calculators have trig functions. Just punch in the angle and hit tangent, and it gives us 0.2679. Now all we have to do is solve for that. Just work this division problem here. Okay, so 0.0015 divided by 2679 gives us 0.0056, which is the value of x. Okay, so if we take our cutter we just ground, touch the surface of the part, move in basically 6 thousandths, we'll end up with a 3 thousandths wide V groove in it. So that's pretty much it. That's basic trig. You'll use, if you don't know trig or if you're unfamiliar with it, take the time to learn how to solve for a right triangle. It's pretty easy to do. You only have to memorize maybe 3 trig functions and learn a little bit of algebra to solve, but it's well worth your while in the shop. I use this all the time. If you use a sine bar, you use a sine function all the time to figure out how large of a stack of gauge blocks to put under your sine bar to get the angle that you need, that you're looking for. So you know, if you're not familiar with trig or you're rusty on it, take some time to brush up on it. It'll be a big help and save you a lot of time in the shop. There's not much to cut in this thing. Just basically put the part in the vise. We'll have to sort of line up the cutter here, get the rotation right. Just got a protractor here. We'll just put a protractor against the side of the tool and rotate it until it's... I got the protractor set at 15 degrees, half the angle. So we just got to get the thing about square with the vise. I'm just sighting alongside the vise here. This is not a critical alignment. That's about right. I'm going to lock the spindles so the thing doesn't rotate. Now, let me zoom in a little bit so you can see what's going on. Whoops, wrong way. Alright, there we go. Okay, you see I've scribed a line where the our cut needs to go, so I'm just gonna eyeball that, just line it up visually. First, let's set the depth. That's about all farther we need to go, so I'll set my depth stop there. So, I'm going to take a little artistic license on this part. If you look on the print, you'll see there's a where are we at here? Okay, you see it's the zero mark is 100,000ths or a tenth of an inch long. I'm going to ignore that. I'm going to make it go all the way through. So if I did that, I'd have to go from the other side, and I'd need a boring bar and a different setup. This is this is a lot simpler. Since it's my design, I can take some artistic license and do it however I want. You can do it however you want too. Alright, so all I'm going to do is just eyeball point of the tool up with the scribed line. Right about there. Then I'll just bring it out till it scratches the surface. Right about there. Zero my readout, move in 6/1000ths. Now 5.8 if you want to get technical, right? And then just cut it. One cut's all it took. So the last operation, now that we have the index mark put in, last operation is to cut these two steps on the bottom side. One of them is just clearance, and the other one is the other one rests on the bottom of the way of the Atlas lathe. So that I rebuilt. The reason I have this note on here. It says this dimension must equal the thickness of the ways on your lathe plus or minus 10/1000ths. The reason I did that is because the lathe that I built this for, I rebuilt for my dad, and I ended up milling the ways to get the bow and the wear out of them. So they're a little bit thinner than the stock ways on an Atlas. So I would just recommend that before you make this cut, you measure the thickness of your ways and make it the same depth as that dimension. Just match it to your lathe. I have no idea what the original dimension was. That's why I didn't put it on there. But just measure yours. Life will be good. So to do that, we just mount this part on a couple parallels. Now remember we have this pad sticking up on the bottom, on the top here, so we have to make sure that doesn't interfere with our parallel. I'm using a thin parallel, so it doesn't matter. It's not going to hurt anything. It's not going to be resting up on top of that pad. So we'll just put it in the vise, hammer it down on the parallels. I think we'll do this shallow relief cut first. It's 100,000ths deep and 1.1 in from the back. So for something like this, I just run my tool down against the quill stop, pick up the top of the part, out there, zero my knee out. And then I'll move off to the side and move down, not 100,000ths, I won't go the full depth, I'll go 90. I'll leave a little bit for a finish cut. And then I'll run the end mill against the back side, pick up that surface. Right there. Zero my dial out. Now I know I have to go in 1.1 So I can go ahead and take this cut. There's about 800,000ths. Here's 1.1 and 1/15. That'll leave a little bit left for a finish cut. Okay, so now I'll go down to the full 100,000ths depth and the full 1.1 distance in. Just take the finished cut here. I almost always climb mill on a finished cut. It makes a much better finish, in my opinion, than conventional milling. And move over about 400 thousandths. We got a little bit of overlap. Okay, there's that cut. Now the next one I laid is, I said it was 352 thousandths, so we got to go down, let's see, 1, 2, 3, 342. And this cut for the clamping part on the ways is a 1/2 inch from the back. I think we can do that. We'll do 490 first cut. Leave 10 thousandths for finish cut. And, there. Now again, if you're using a light mill, you can't do this. You have to adjust the cut depth, the size of your cuts for whatever machine you're using. You might have to take 3 or 4 cuts to make this cut instead of 1. So you just have to know your machine. And you won't be able to climb mill on this deep of a cut either. Okay, even after conventional mill. Alright, there's the roughing cut. Move in the full 1/2 inch from the back. And the full 300, what did I say, 352 depth. Right there, let's take this finished cut. Alright, let's get some burrs off of it. I think that's about it. Let's see here. A couple more burrs inside. Alright, so now we're finished. I think we're finished. All it's left to do is make it look pretty. I'll probably draw file the machining marks out of the top, blend them into these radii. I'll just use a mill file and draw file it, make it look pretty. Make sure all the burrs are cleaned off. Everything's chamfered. And that's about it for this part. I think next we'll probably move on to the spindle. It fits in this hole, and we can make that up. And I think that'll be a good second step to this project. So we'll see you then.